Hello everyone, so today we will learn about number system. Here we will learn on different topics relating to number of factors, power of p, division rule, units, digits, number of prime factors and number of zeros. Here we're going to learn on when leaves remainder, also divisibility rules. In these divisibility rules we'll learn entire different numbers and least value and greatest value. Also we'll learn about few useful formulas and other topics too. So let's start. Right, let's see face value and place value. If we take a number 6, 8, 7, 2, the face value for 6 is 6, and for another example, if we take number 7 and 4, 6, the face value of 9 will be 9. Okay, let's see the place value. The place value will be example 70984. The 7 will be 7 into the number of letters like thousands, and for the 0 it will be 0 is always be 0, and the place value for 9 will be 900, 9 into 100, and 4 will be 4 into units place. Okay, so in this way we'll see the place value and the face value. Okay, let's learn on various types of numbers. Okay, the first number is natural numbers. So natural numbers are counting numbers. They are denoted by n, and this could be 1, 2, 3, 4 and so on. And the second is whole numbers. The name itself indicates whole, wo, which is 0, 1, 2, 3 and 4. The third thing is integers. Okay, we can see it integers. It's a t, so it's dividing 0, 1, 2, 3, 4 and minus 1, 1, minus 2, 3, 4. And even numbers, those which are divisible by 2 are called even numbers. Okay, example, we can see 2, 4, 6 and 8. So next we want to see about odd numbers. So odd numbers is which is not divisible by 2. So few of the examples are 1, 3, 5, 7, 9 and 11, etc. So prime numbers. So prime numbers are counting number which exactly divisible by 1 and itself. So few of the examples are 2, 3, 5, 7, 11, 13 and etc. So let's see on composite numbers. Those are which are not prime numbers are called composite numbers, so which have greater than 2 factors. And let us see about perfect numbers. So the perfect numbers are which have sum of factors equals to number of factors. The number of factors and the sum of factors will be same. So example, you can see 6, 28. Okay, so if we're gonna take number 6, we can see the factors are 1, 2, 3 and 6. So 1 plus 2 plus 3 equals to 6, so it's called a perfect number. And 28, and if we take the 28, there will be factors called 1, 2, 4, 7 and 13, 14 and 28. If we add them, it will get 28. So let us see coprimes. Coprimes are which the HCF will be equal to 1. So examples could be 2 and 3 and 8 and 9. So let us see on twin primes. Twin primes, the difference is 2. So the twin primes could be 3 and 5, 5 and 7, 11 and 13. So let us go ahead with, let us see on rational numbers. So a number that can be expressed as p by q, where p and q are integers, are called rational numbers. So there could be a few examples. And irrational numbers, the numbers that cannot be expressed in the form of p by q, are called irrational numbers. Example, root 3, root over 2, root 7, root 11, 5. So let us start on divisibility test. So test of divisibility, it is easy to learn. So number one thing we're gonna learn is about divisibility of 2. So how to? So when the last two digits are either 0 or even, the entire number will be divisible by 2. And divisibility of 3, when the sum of the digits of number is divisible by 3, the number is divisible by 3. So for example, we could see 695421. If we add the entire number, we will get 27. It is divisible by 3, so the number is divisible by 3. If we take 9, 4, 8, 6, 5, 3, if we add it, we'll get 35. 35 is not divisible by 3, so it is not divisible by 3. And now we'll taking 9. So here the sum of the digits of a number should be divisible by 9. The number is also divisible by 9. So if we take a number, for example 2, 4, 6, 5, 9, 1, the sum will be equal to 27. So it is divisible by 9, so it is divisible by 9. If we take 7, 3, 4, 5, 9, 1, 9, it is 29, it's not divisible by 9. So let's take 4. So for the last 2 digit number should be divisible by 9, divisible by 4. Okay, for example, if we could take a number like 6, 8, 7, 9, 3, 7, 6, we should be seeing the last 2 digit numbers. Okay, so the last 2 digit number is 7, 6. So 7, 6 divisible by 4. Example like 6, 1, 3, 8, last digit 2 number is not divisible, so it's not divisible by 4. Let us take 5. So numbers should having 0 or 5 at the end are divisible by 5. So we know it. Let us see this divisible by 8. So when the number of last 3 digits of number is divisible by 8, then the number is also divisible by 8. Apart from this, last 3 or more digits of a number are zeros, then also it is divisible by 8. Let us see the divisibility rule for 10. So we know this, so no need to discuss. So let us go ahead with 11. So when the sum of digits at odd and even places are equal or difference by the number divisible by 11, then the number is also divisible by 11. Let us take an example. So here I took with black alternative and red alternative. So we will see the difference between them. So 7 plus 4 plus 3 plus 9 minus 1 plus 5 plus 4 plus 2. The difference is 23 minus 12 is equals to 11. So it is divisible by 11. Let us see 5, 7, 4, 6, 3, 8, 2, 2. So let us take the alternative positions and let us add. So it will be 23 minus 14 is equal to 9. 9 is not divisible by 11, so it is not divisible. Now let us see 25. So the last digit should be either 25 or 00. Now let's begin with 7 or 13. So for the divisibility rule of 7 or 13, the number of the group of digits should be 3. Let us see and the find difference. So it should be either 0 or it should be divisible. Let us take an example. 5, 7, 9, 4, 8, 8. So we will first divisible, make it part by part as 3, 3, and divisible. If it is divisible by 7 and 13, so 91 is divisible by 7 and 13. So it is divisible by 7 and 13. So let us take a few examples like 12, 6 and 13. If we take 12, divisible by 3 and 4. If we take 6, it should be divisible by 2 and 3. If we take 15, it should be divisible by 3 and 5. So let's go ahead. If we take 18, 2 into 9, so 2 and 9, 24, 3 into 8, 3 and 8, and 40, 5 into 8, and we'll take 80, 5 into 16. So the number is divisible or not, we will see the multiples. So it will be easy for us to see the divisibility. So let's start with the prime number. How to check whether it is a prime number or not. So as we start checking the prime number or not, let's take an example. If we take a number 137, we need to see the nearest square to that. Okay, so 137 nearest square will be 144. The square should be greater than 137. So 12 square, it is 144, and we will see the square. Okay, so it should be greater than 137, and 12 multiples will be 2, 3, 5 and 7, and we will see whether any of these multiple are divisible by 137. So no multiple, I think, is not divisible by 2, 3, 5 and 7, 11. So 137 is a prime number. Let us take also another example. So as we seeing this, we will take an example of 437. Okay, so the 437, we will see the nearest neighbor square will be 21 square. Okay, so 21 square will be greater than 437. So 21 multiples, we will see the 21 multiples are 2, 3, 5, 7, 11 and 13, 17 and 19. So 2, 3, 5, 7, 11, 13, 17 will not be divisible by 437, but only 19 will be divisible by 437. So 437 is not a prime number. Okay, if any of the multiple is divisible by the number, it's not divisible by, it's not a prime number. So let us start with the important formulas. So what are the important formulas? A plus b whole square is equals to a square plus b square plus 2ab. And a plus b whole square plus a minus b whole square will be 2 into a square plus b square. But let us see what is the contrary to a minus b whole square. A minus b whole square is equals to a square plus b square minus 2ab. Okay, so we will all see contrary to a plus b whole square minus, okay, a minus b whole square, it will be 4ab. Okay, a plus b whole cube, a plus b whole cube, we will see that a cube plus b cube plus 3ab into a plus b, and contrary to that a minus b whole cube will be a cube minus b cube minus 3ab into a minus b. A square minus b square equal to a plus b into a minus b, and a plus b plus c whole square equal to a square plus b square plus c square plus 2 into a plus ab plus bc plus ca. Now a cube plus b cube equal to a plus b into a square plus b square minus ab, and a cube minus b cube contrary to that equal to a minus b into a square plus b square plus ab. So the next one is a cube plus b cube plus c cube minus 3abc will be a plus b plus c into a square plus b square plus c square minus ab plus minus bc minus ca. And finally, if a plus b plus c equal to 0, then a cube plus b cube plus c cube equal to 3abc. And also let us see here there is positive and negative, and we can see where are the negative signs and positive signs. Do not confuse. So in the a minus b whole cube there will be minus, negative, positive, negatives, and just try to by heart these things because these are basic formulas that we need to really important to by heart. And let us see the factorial. So the factorial for n factorial will be n into n minus 1 into n minus 2, so on up to 3 into 2 into 1. So example for 5 factorial, 5 into 4 into 3 into 2 into 1 will be 120. For 0 factorial, this 1. So let us see number of factors. How many number of factors in a given number? So if you're gonna take 60 or 70 examples, so we're going to take 60. So if n equal to a power p into b power q into c power r, then number of factors will be p plus 1, q plus 1, r plus 1. So this is the number of factors is equal to p plus 1 into q plus 1 into r plus 1. So let us go ahead with number of primes. So the number of primes will be p plus q plus r. Okay, so we will also see number of different prime numbers. So the number of different prime numbers here will be the different prime numbers which will be used in the formula. Okay, so let us see an example here. The example will be 60. So to see how many number of factors, we will see the multiples of it. So by LCM we can get the multiples: 2 into 30, 2 into 15, 3 into 5. So we'll see. So for the number of factors we need to know the powers, right? So 2 power 2 into 3 power 1 into 5 power 1. So add the powers, 2 plus 1 into 1 plus 1 into 1 plus 1. So 3 into 1, 2 into 1, 2 is equal to 12. So the number of factors will be 12. So for the number of prime numbers, we need to add on the powers. So 2 plus 1 plus 1, it will be 4. Okay, so 2 plus 1 plus 1 will be 4. And number of different primes. So the different primes, there are 2 plus 1 plus 1 is also 4. Okay, let us see another example. Multiples, we will get 3 square, 7 power 1 into 11 power 1 into 13 power 1. Okay, by taking the LCM we can get 3 square into 7 power 1 into 11 power 1 into 13 power 1. So by first thing we will say the factors, 2 plus 1 into 1 plus 1 into 2, 1 plus 1 into 1 plus 1. So 3 into 2 into 2 into 2 will be 24. And let us say the number of primes, it will be 2 plus 1 plus 1 plus 1 equals to 5. And third one is different primes. There are 4 primes, so there will be 4. So let us see how to find the power of p in factorial. So n factorial will be n by p power 1 plus n by p square plus n by p cube and so on. So let us see an example. So power of 2 in 4 factorial. So let us write 4 by 2 power 1 plus 4 by 2 square plus 4 by 3 square 2 cube. So 4 by 2 will be 2 and it will be 1 and anything decimal will be 0. So it is 2. The power will be 2. And now going ahead, power of 3 in 4 factorial. So it will be 4 by 3 power 1 plus 4 by 3 square. Anything greater will be 0, so it will be 0, and 1 plus 0 is equals to 1. Another example, power of 3 in 18 factorial will be 18 by 3 plus 18 by 3 cube 3 square plus more than anything 0. So okay, so 6 plus 2 is equals to 8. So it is power. So let us learn on division rule. Division rule, it's very important to remember because there are many problems. So let us take 8 and 42. So 8 will be the divisor. So as the divisor, left side will be the divisor and the right side will be the quotient and the down is the remainder, and this is called dividend. Okay, the formula for this is d is equals to d into q plus r. Divisor is noted, dividend is noted by d and divisor is noted as small d. Okay, so let us see how to do it. And so the smallest number and the largest number, so 4 digits. For the smallest number of 4 digits will be 1000 and 9999, and 5 digits it will be 10,000 and 99,999. 6 digits will be 1 lakh, and here it will be 9,99,999. So here we need to remember carefully that greatest digit number will be biggest minus remainder. Smallest number will be least plus divisor minus remainder, and here r is the remainder. Okay, let's go for the first example. Okay, so seeing what is the greatest number of 5-digit number exactly divisible by 231. So this is the question. 5-digit number, greatest 5-digit number which is exactly divisible 231. So the 5-digit number is 99,999. Okay, by 231. So we need to see here minus remainder. So here is the remainder. So we will divide. So 231 99,999 we will divide, and by dividing we will get the remainder 207. Okay, so the remainder is 207 and the dividend minus biggest minus remainder. So 99,999 minus 207 will be 99,792. So seeing the second example, so they asked least 6-digit number which exactly divisible by 175. Okay, so we are seeing here least 6-digit number which is exactly divisible by 175. So we'll take 175 and we'll divide with least. Okay, least which will be 1 lakh, right? 6-digit number will be 1 lakh. Okay, when we divide, we will get the coefficient 571 and the remainder will be 75. Okay, so as the remainder is 75, we'll see the smallest is equals to least plus divisor minus remainder, right? So smallest will be least plus divisor minus remainder, so it equals to least will be 1 lakh plus divisor is 175 minus 75 equals to 1 lakh 100. So this is how we will do the division rule, and we will have remaining in the practice session. So alright, so let us start with basic number theory. It is very important, these theory numbers. So let us see. So few of them will be, the number one will be sum of first n natural numbers. The sum of first n natural numbers will be n into n plus 1 by 2. So the example will be, if we take first n 25 numbers, 25 into 26 by 2, so it will be 13. So in the same way we'll do remaining. So the sum of first n odd numbers will be n square. Okay, so the sum of first n even numbers will be n into n plus 1, and the sum of square of first n natural numbers will be n into n plus 1 into 2n plus 1 divided by 6. So also the sum of cubes of first n natural numbers will be equivalent to n into n plus 1 by 2 whole square. So also the primes, they may ask this question. So first they'll be, for first 1 to 50 numbers there are 15 primes, and for the 50 to 100 there are 10 primes. Totally 1 to 100 there are 25 primes. Okay, so this is the one another, and x power m minus a power m is divisible by x minus a for all values of m, x plus a for all even values, x plus a for all values. See here, you can see it clearly. So x minus a, x plus a for all even numbers, x plus a for all odd numbers. So you see it clearly, so you can understand it.